Hi, welcome to a brand new section on Mastering R Programming video course. We have covered the essential and advanced topics related to data analysis, machine learning, and visualization. However, traditionally, R is said to be slow when it comes to computation speed. But with the development of powerful speed-enhancing packages and the right coding practices, we can achieve tremendous computing speed in R. This entire section is about exploiting those techniques. We begin this section by understanding best practices related to writing fast R code and the pitfalls that can make R slow. The techniques covered in the remaining 4 videos require additional packages and can make the computations exceptionally fast. Let's begin this section with the best practices to speed up R code. In this video, we benchmark and profile an algo that uses a for loop. Then, we see the following techniques that progressively improve the computation speed. Here's a data frame with around 20,000 rows and 4 columns. We will build a simple logic where we create a new column that contains a string greater than 4 if the sum of the 4 columns in a row exceeds 4. Else, it will contain the string less than 4. We build a basic for loop to do this operation. Then we examine ways to improve code, runtime, using various basic and advanced techniques. Let's benchmark the elapsed time of the logic that uses a for loop. The micro-benchmark package provides an excellent tool to benchmark code, runtimes. For each row of the data frame, we check if the sum of the 4 columns is greater than 4. If it is greater, then in the 5th column we write greater than 4, else we write less than 4. Micro-benchmark function runs this for loop 10 times. So, the mean time taken is 3.919 seconds. If you wish to know which parts of code takes the longest to compute, just select the lines and choose Profile Selected Lines in the Profile menu in RStudio. This shows the computation times for each step in this logic. Alright, let's reset the data frame. The first step to improve the speed is to vectorize and pre-allocate the size of the output. The output vector was pre-allocated before beginning the loop. The mean time taken is now 1.19 seconds. Another option is to use the apply family of functions. This one is much faster and it just took 118 milliseconds. Using byte code, compilation, along with the apply family of function can make it slightly faster. That reduced the mean speed from 118 to 96 milliseconds. Sweet! Going back to for loop logic, we can improve it further by moving statements that check for conditions outside the loop whenever possible. Here I have moved the condition check outside the loop. This took just 22 milliseconds, which is much faster. Further, we avoid a significant number of iterations by running the for loop only for true conditions. Here, we initialize the output to have the string less than 4 by default. Then, the loop is run only for the true condition. This further reduced the time to just 15 milliseconds. Another option is to use if-else statements whenever possible. The time taken has come down to less than 5 milliseconds. If we use the which statement smartly, we could get it done even faster. The mean time is now less than 2 milliseconds. If you are not in a position to create a separate vector and append it to the original data frame, you may consider the set function in the data.table package. The set is actually a very powerful function that makes assignment operations almost instantaneous. It takes a data frame or data.table as the first argument, followed by row and column numbers, and finally, the value to be assigned. The third argument could be a column name as well. This brought the speed from 4 seconds in original logic to 1.2 seconds. Excellent! So here's the challenge for this video. Speed up the following logic to the maximum speed possible. And here's my version of the answer. So using set function, I was able to get 23 milliseconds.